contain a lot of useful information on functions. One thing that we can pull from a function is whether a function is increasing, decreasing, or constant. It's important to note that when we are reading a graph to determine if it's increasing, decreasing, or constant, we always read from left to right. We say a function is increasing over an interval if f of x2 is greater than f of x1 for all x2 greater than x1 in that interval. We say the function is decreasing over an interval if f of x2 is less than f of x1 for all x2 less than x1 in a given interval. And we say it's constant if f of x2 is equal to f of x1 for all x1 and x2 in the interval. So let's look at what this really means and how we can pull this information from a graph. When we read a graph from left to right, the idea is if it's going up from left to right, then that means the graph is increasing. But if it's going down from left to right, that's going to be decreasing. And then constant would mean that the y values are not changing. The graph is flat there. Let's consider this graph here, and we want to see where it's increasing, where it's decreasing, and where it's constant. As we go along the graph from left to right, we can see that we're moving up as long as x is between -4 and 2. -4 and -2. Therefore, this function is increasing from -4 to -2. After that, we can see the function starts moving down as we move from left to right, and that happens between x equal to -2 and -1. Therefore, this function is decreasing on the interval -2 to -1. After that, the function is straight, so that would be constant. So we say this function is constant on the interval from -1 to 2. And then finally after that, we can see that it's going down again as we move left to right. That tells us that this function is also decreasing over the interval 2 to infinity. Another piece of information that a graph can give us is the values of local minimums and local maximums. A local minimum occurs anytime the graph moves from decreasing to increasing. These are sometimes known as the valleys. A local maximum occurs anytime a graph moves from increasing to decreasing. These are sometimes known as the peaks of the graph. And it's important to note that these local minimums and maximums do not need to be the minimum or the maximum of the entire graph, but rather just a peak or a valley on the graph. Here is a picture that kind of shows us what we mean by this. The local maximums are these peaks on the graph, and the local minimums are the valleys on the graph. Let's look at this graph here. Let's look at where it's increasing, decreasing, and constant, as well as the local max and mins. So once again, we need to read from left to right. As we start, we can see the graph is going up. This tells me that the graph is increasing from -4 to -2. After that, it's moving down and to the right. That tells me it's decreasing between -2 and 0. We then start moving back up. So we are also increasing on the interval 0 to 2. And then finally, we move back down. And we are decreasing between 2 and infinity. Now let's start to look at our max and mins. The maximums are my peaks, which I can see I have 2 of, here and here. This tells me that I have local maximums at the points -2, 1 and the point 2, 2. For the minimums, I'm looking at valleys, and I only have one of those that occurs at this point here. This tells me that my local minimum occurs at the point 0, -1. In addition to a local maximum and minimum, we can also have an absolute maximum and minimum. The absolute maximum of a graph is the point on the graph with the largest possible y-coordinate. The absolute minimum of the graph is the point with the smallest possible y-coordinate. And it's also important to note that a graph may not have an absolute minimum or an absolute maximum. Let's look at this graph here. My absolute maximum is going to be the point with the largest possible y-coordinate, which would be the point 2, 2. However, since this graph does go down forever, I don't have a smallest possible y-coordinate. So there is no absolute minimum for this graph.